Have you ever been to a party where everyone is talking and shouting at once? It's impossible to have a simple conversation. Computer networks face the exact same problem. When you have dozens of computers, printers, and servers all connected in the same building, how does a message get to the right place without getting drowned out in the noise? In the early days of networking, we solved this connectivity problem using a device called an Ethernet hub. You can think of a hub as a giant digital megaphone. But hubs had a major mechanical flaw. If a computer sent a file to a printer, the hub didn't know where the printer actually was, so it just duplicated that file and shouted it out to every single device plugged into the network. Everyone had to listen to everyone else's traffic. Because of this, massive data collisions happened constantly. Networks built on hubs were notoriously slow and incredibly inefficient. To fix this traffic jam, engineers developed the modern network switch. Unlike a hub, a switch doesn't shout. It identifies exactly who the incoming message is for and creates a direct, private pathway just for that specific data. Introducing this basic intelligence turned chaotic broadcasting into the high-speed, private communication systems we rely on today. But how exactly does the switch pull this off? If you plug 20 identical cables into the back of a box, how does it know which device is at the end of which cable? It relies on something called a MAC address. Think of a MAC address as a permanent, unique digital name tag that is physically built into every computer, phone, and printer right at the factory. When you first plug everything in, the switch starts passively listening. Every time a device sends a bit of data, the switch looks at the sender's MAC address and notes which port it came from, building a map of the network. Once that map is built, the switch knows exactly where everyone lives. So when a new message arrives, it checks its list and instantly forwards the data to the correct destination port, completely ignoring the rest of the network. This ability to automatically learn and map its environment is what makes a switch a smart device. You don't have to program the map yourself. You just plug in the cables and the switch figures out the rest. Knowing where to send the data is only half the battle. The switch also has to decide exactly how to move that packet of information, balancing speed against accuracy. This engineering text shows the two main methods switches use to move those packets: store and forward and cut-through switching. In store and forward switching, the switch receives the entire packet, holds it in memory, and scans it for errors. If the data is corrupted, the switch drops it. If it's perfect, it sends it on its way. Cut-through switching takes a much faster approach. The switch reads only the destination address at the very front of the packet. The moment it knows where the data is going, it begins pushing it out the destination port before the back half of the packet has even arrived. Cut-through provides lightning-fast delivery, but runs the risk of forwarding broken files. Store and forward ensures the data is correct, but takes slightly longer to process. Network engineers decide between these methods based on whether a specific network needs absolute data perfection or ultra-low latency. At this point, you might be thinking this sounds a lot like a router. People often use the words switch and router interchangeably, but they are different devices doing different jobs. A switch operates strictly within the network of a single building. Its only job is to connect devices in one specific place, like your office or home. A router bridges the gap between entirely different networks. If your computer wants to talk to a server halfway across the world, it needs a router to translate and pass that data onto the global internet. Think of the router as border control, connecting you to the outside world. The switch is the internal highway system, making local communication possible. Modern office switches can actually power devices as they move data. Using a feature called Power over Ethernet, a single cable can carry electricity to run a security camera or an office phone without needing a separate wall outlet. These professional switches give IT teams massive control. This diagram shows status lights for things like connection speed and whether data is moving in both directions at once. We have come a long way from the early days of hubs blindly shouting data down the hallway. The network switch is why your office network stays fast and orderly, quietly making sure every piece of data finds its way to the right person.